Now we will see some of the most important math function possible using NumPy. Basic mathematical functions using the operators plus, minus, slash, star operate on element wise on arrays. So for example, you have two arrays, NumPy arrays x and y. Both of them are of two-dimensional arrays of shape 2 by 2. X and y are 2 by 2 matrices. So if you apply x plus y, this calculates element wise addition on the matrices x and y. This can also be done using nb.add method. In that case, you need to give nb.add x comma y, or simply you can give x plus y. So both of them produce the same result. So if you use operator minus, that is element wise difference. So for that you can give x minus y or nb.subtract of x comma y. And star will do element wise product. This can be done using x star y or nb.multiply x comma y. Element wise division is possible using the operator slash, and it can be possible using x slash y or nb.divide x comma y. Likewise, there is element wise square root, which it takes square root of each of the given elements of the matrix. It is possible using the function nb.sqrt of x, where x is the matrix for which element wise square root should be found. There is a dot function to compute the inner product in the case of vectors, one-dimensional vectors, and it will calculate vector matrix multiplication if both of the operands are two-dimensional matrices. For example, here you have four matrices, x and y both of size 2 by 2, and v and w are one-dimensional vectors. So if you apply dot operator, dot function on v and w, where v and w are one-dimensional vectors, this dot operator will calculate the inner product, and which will produce the output as 219. This inner product can be calculated using v dot w or nb.v comma w, where v and w are vectors, one-dimensional matrices. So this is calculated as 9 into 11 plus 10 into 12, that is 219. You can also use the at operator for calculating the dot product. So in that case, you just need to give v's at w, where v and w are one-dimensional matrices. So in the case of where the operands are matrices, they are rank 2 arrays, two-dimensional arrays. Here in that case, x and y are 2 by 2 matrices. In that case, this dot operator or x at operator will calculate the matrix product. So this can be calculated using x dot y or nb dot x comma y or x at y, and this will calculate the matrix product of x and y. So we will be getting the same output for these three. So there are many useful functions provided by NumPy like this. One of the most useful is sum. This sum method will compute sum of the all elements. So nb.sum of x will give you the sum of all the elements of the matrix x. So this will calculate 1 plus 2 plus 3 plus 4, that is 10. So this sum method can take arguments. You can give the axis. If axis is 0, then column wise sum is calculated, and if axis is 1, row wise sum is calculated. So these are some of the important NumPy based mathematical functions.